Good day, students. Welcome. Today we're going to discuss the last topic of this course in GE 102 Geometric Geodesy, which is talks about geodetic datum and datum transformation. Here is for the authors and contributors of this material, and here is for the copyright notice. For the outline of the presentation, we have two parts for this lecture. The part 1 will be talking about the definitions and properties of geodetic datums, interrelationship of geodetic datum, reference systems, and reference frames, commonly used geodetic datum and reference systems, the Luzon datum 1911, and the PRS 92, and lastly is the World Geodetic System of 1984. For the part 2, we're going to talk about the datum transformation methods and the transformation from WGS 84 to PRS 92 and vice versa. For the intended learning outcomes, after this lecture and exercises, you the student must have first define the geodetic datum, illustrate and discuss their properties and properties of geodetic datum, differentiate geodetic datum from reference system and reference frame, illustrate and discuss the interrelationship of geodetic datum, reference system, and reference frames, identify and describe the commonly used geodetic datum and reference frame, discuss the Luzon datum 1911 and the PRS 92, and lastly is to discuss the World Geodetic System of 1982. So we were going to recall now about geodetic datum. So geodetic datum is a set of parameters that describe the relationship between a particular local ellipsoid and a local geodetic reference system. So a geodetic datum is defined by a set of at least 5 parameters, namely the semi-major axis of the reference ellipsoid, the flattening, and the x, y, and z coordinates of the ellipsoid's origin with respect to the geocenter. So, anong kinahanglan siya x, y, and z? Kasi geodetic datum will be the basis for the origin, no? The origin of that system, the origin of the geodetic reference system to be used, no, by the survey ginakandak your local, no? So kinahanglan siya na ay particular relationship between local ellipsoid and the geodetic reference system. Okay? Since we all know nga in different countries is dapat na-adjust siya datum. And geodetic datum is a set of parameters and constant that defines a coordinate system, including its origin, its orientation and scale, in such a way as to make this accessible for geodetic applications. There are types of geodetic datum, namely the horizontal geodetic datum. This is for horizontal geodetic control, in which points are mapped into the specified ellipsoid. So, pamoingon ta og horizontal, it's merely for horizontal control, the establishment of a geodetic datum for horizontal geodetic control. So, pamoingon ta og horizontal 2-dimensional. And this datum is a 2-dimensional, as what I have said a while ago, in the sense that two coordinates, the latitude and longitude, are necessary and sufficient to identify a point. Diba? Pag naatay latitude and longitude, we can specify the location of the specific point. And we have next type is the vertical geodetic datum. It's a geodetic datum for vertical geodetic control, in which points are mapped in a geopotential. And this datum is only 1-dimensional and requires the value of a single parameter, so which is the origin of the point, to be realizable. So example ani niya is ang mean sea level. So there are examples of horizontal geodetic datum. We have the WGS 72, WGS 84, and PRS 92. So mani siya ang mga example for geodetic datum. And for vertical datums, we have the mean sea level. So ano siya mean sea level? Kaya na ay tawag na low tide, napuntay high tide. Pero kuha ko na to ang mean out ana niya. So dili pud ta basta-basta makabuhat og mean sea level, no, or maka-create og mean sea level, guys, because the creation of the mean sea level takes 19 years, no? 19 years continuous observation para makakuha tayo ng mean sea level. So these are the datums, no? Geodetic datums used by different countries. So ang kaning inganing forma ng legend niya is mao ni siya. So ang tawag niya is North American datum, ang uban kay European kani siya, naapoy Tokyo, Indian, and so on and so forth. So for this video about datum, so since di na ko siya ma-play diri so I'm going to attach the video in the in our LMS, no, for you to have the video. I hope nga inyo siyang tanawon para masabtan ninyo kung unsay pasabot sa datum. And let's go to the reference systems and reference frames. So it's a recall again. It's this is discussed in your geometric geodesy, no? So reference system is a complete conceptual definition on how a reference coordinate is formed, and it defines the origin and orientation of fundamental planes and axes of this system. So pag may reference system is the whole conceptual, na the concept of the system, and it also includes the underlying fundamental mathematical and physical model. So since kay concept pa man siya, so ang basis niya is or ang fundamental niya is ang mathematical and physical models. And when we say reference system is it is an attached, no, an attached to the real world, kay since conceptual pa siya, floating pa siya, no, wala pa siya na realize. And that realization is what we call reference frame. It's a practical realization of a reference system through observations. It realizes the reference system by means of coordinates, no, coordinates of definite points that are accessible directly by occupation or observation. It consists of a set of identifiable fiducial points on the sky, like stars and quasars, or on Earth's surface, example, fundamental station. So, si reference frame ko ang mo realize, no? Another simple scenario or simple analogy, no? Simple analogy of reference system versus reference frame is kanang si reference system is mura na siya og kanang resita sa doktor, resita concept pa na siya gikan sa doktor nga mauni ang makaayo sa imong sakit. It's a prescription na siya, prescription. And now kung since kay concept pa man siya, i-realize na nimo once mapalit na nimo na ang tambal. So ang kanang tambal karon mao na siya ang reference frame, no? Kumbaga ang kaning sa reference frame mo realize sa reference system. So saan pag-realize sa reference frame? Through monuments, kanang mga BBMs, geodetic control networks and stations out of that system. Useless reference frame kung wala si reference system, and vice versa. Useless po si reference frame kung wala si reference system. And in practical surveying, we are only concerned with reference frames. Of course, kay ito ta mag-base sa ato ang survey, no, sa mga monuments. But underlying concept of a specific reference frame are fundamental importance. Of course, no, so kung panggiingon, useless sa reference frame kung wala si reference system, and vice versa. So another analogy of the reference system versus reference frame is this chessboard and chess pieces, no? So without a reference frame and coordinates of control points are like chess pieces without a chessboard. So atong ipalagay nga ang kaning chess pieces is mao ni siya ang reference frame, and ang kaning chessboard is ang reference system. So kung wala daw ni si chess pieces is useless ni si chessboard. So kung may gamit niya kung wala ning chess pieces, and vice versa, no? So useless pud ni si chess pieces kung wala pud ni si chessboard, or si chessboard kung wala si chess pieces. So they can be arranged, analyzed, and moved, but they have no meaning. Okay, kung nakaaning mga pieces, which is pieces, so i-move lang nimo into this direction kung asa iyahang movement, pero wala ka kabalo, na siya padulong, no? So murag walay direction ang imong buhat kung wala ang chessboard. So useless ang reference frame kung wala ang reference system, and vice versa. So for the relationship between the reference system, geodetic datum, and reference frame are from the reference system, no, which is the whole concept of the a system. So example of reference system is the terrestrial reference system. Output niya is ang geodetic datum by realization of the reference frames. And from that geodetic datum, horizontal datum, example niya, so kung natay geodetic datum, natay reference sa atong origin, and from reference datum, we will now having the reference frame, the realization of the reference system. Out from the geodetic datum, we can create a reference frame like GCP, benchmarks, and BLLMs. So here are the example of some ellipsoids, no, that was used in today. So na ay Airy, si Bessel, si Clark 1866, Clark 1880, Clark 1880 nga modified, Everest, and so on and so forth. So we have also these datums that will use that was used across the world. Daghan kini sila class, isa-isa ko na ninyo nagbasa ha, kamo na bahalaan. So we have also there Indian, and in the Philippines we have Luzon. Luzon datum. Ang iyang ellipsoid is si Clark 1866. So daghan kini sila class, kamo na magbasa. Alright, so let's go to the discussion on the Luzon datum of 1911. For its brief background, the plan of the United States to survey the Philippine Islands was begun on March 1900s. And when a United States Coast and Geodetic Survey, or USCGS, so since 1900s is the time, no, nga gisakop ta sa Americans, no. So the USCGS, no, was conducted, no, survey of establishing geodetic control networks in the Philippine Islands that was begun on March 1900. So an officer was sent to Manila with instruction to prepare a report of an existing cartographic conditions in the Philippines and to obtain all the information necessary for the execution of geodetic, hydrographic, and topographic surveys in the country. So syempre mag-recon sila kung unsay existing na maps na ginagamit sa Philippines, and dito sila mag-start sa ilahang survey para unsay necessary na ilang buhaton, no, kung na ba existing or wala pa. So from 1901 to 1911, the USCGS established several triangulation networks all over the country, which had different origins. Since di pa man also ang GNSS before, so they are using the old the conventional method on establishing geodetic control, no? So which is the triangulation. In 1911, these different networks on the different datums and with different origins were consolidated into nationwide network, and the Luzon datum was established with the triangulation station Balanacan as its datum origin. So after they got all the informations na unsay naa sa Philippines before pa ang 1900s, so nanay nang establish nga mga reference points, but different origins, different regions ang ilahang gina referan, no? So dili siya harmonious or dili siya isa, murag dili siya tibo kumbaga ba. So lahi-lahi sila og reference. But after the team, no, was survey the Philippine Islands, no, and on 1911 ang katong mga series of networks and in different references and in different regions ilang i-consolidate, no, and they decided to establish a datum which is the Luzon datum, and nag-establish sila og triangulation station that was named as Station Balanacan, no. So, si Station Balanacan ang datum origin for the entire country. And the Luzon datum of 1911 was defined by Station Balanacan. Again, gibalik na to, no? Station Balanacan as origin using the station's astronomic latitude, longitude, and azimuth to Station Baltazar, no? Station Baltazar, this is another, by the way, no, si Balanacan is an island, no? And there was another island which is the Baltazar. So dito nila gi-refer ang ilahang astronomic observations, no? So Station Balanacan, and they used, no, the Clark Spheroid 1866 as reference ellipsoid. So si Clark Spheroid, no, ang ilang gigamit as an ellipse model. So the Balanacan station has the following description. So this is the coordinates of the Station Balanacan. Latitude 13 degrees 33 minutes and 41 seconds, and for longitude 121 degrees 52 and 3 seconds. So this is the coordinates of the Station Balanacan. So the azimuth from triangulation Station Balanacan to triangulation Station Baltazar. So since kinasilay gigamit tapod na isa ka station which is from the other island, so kadto siya, mo to siya ang Station Baltazar. So ang ilahang azimuth, no, is 9 degrees 12 minutes and 37 seconds, and nasilay distance si Station Balanacan and Baltazar to be 37,680.90 meters. Ang back azimuth niya is 189 degrees 11 seconds and 50.60 minutes. 189 degrees 11 minutes and 50.60 seconds. So this is mo ni siya ang no? Mo ni siya ang nawong sa Station Balanacan, no? So dako na siya actually nga rock. Then ilaha lang gi-establishan og sign, no, para gamiton siya as origin, no, for the surveys in the whole country. For the another description for Station Balanacan, so ang station mark is in the center of a hole, no, kani siya, no, center of a hole nga naa siya diameter nga 1.5 centimeters, kaning gamay na okay, pen. So this is 1.5 centimeters, no, ang iyang diameter, and 6 centimeters deep, no, paubos gilaw man nila. Drilled at the center of the triangle with 16 cm on a side. So this is 16 cm, 16 cm, then 16 cm. So this is cut in a hard rock. So Mr. O.W. Ferguson established the boat station with Mr. H.D. King as the chief of party. So both the Station Balanacan and Station Baltazar was established by Mr. O.W. Ferguson and Mr. H.D. King as the chief of party. So thus, a geodetic station is said to be Luzon datum. So Luzon datum siya if it's connected, no, by continuous triangulation from the Station Balanacan. So if your reference is said to be in the Luzon datum if your geodetic networks is connected, no, connected by a triangulation station from the Station Balanacan. All right. So the Philippine Geodetic Network, or PGN, developed until 1946, consisted of narrow chains of second-order triangulation station concentrated along the coastal areas for topographic and hydrographic surveys. So most of the triangulation networks was built, no, in the geodetic network rather, no, of the Philippines is established in 1946, no, nga triangulation networks, and mostly it was built in the coastal areas, no, for hydrographic and topographic purposes. The PGN was upgraded into Philippine Reference System of 1992, or widely known as the PRS 92, through an Australian-assisted project from 1988 to 1991. And to date, the Station Balanacan is still the datum origin. So, Luzon datum 1911 was then upgraded into
another step for the more accurate and more reliable geodetic networks. So it was assisted by Australian project from 1988 to 1991. So still si Station Balanacan gihapon ang datum origin. So gi-upgrade lang siya. Ang tawag atong upgraded version so man ang gitawag nga Philippine Reference System of 1992. And during the development of the PRS-92 from 1987 to 1991, there are a total of 360 stations, 332 ang first order and 17 ang second order and 11 only are the third order stations. So GPS GPS ang gigamit for PRS-92 nga network. And of these stations, 69 were common to the primary triangulation network stations defined with the old Luzon Datum. So again, si Luzon Datum is 1911 pa man to, so it was then upgraded into Philippine Reference System of 1992. So ang gigamit na pag-upgrade is ang GPS or kanang Global Positioning Systems. And out of the stations nga na-established from Luzon Datum 1911 to PRS 92, 69 adto ang common stations gi-establish lang siya. So 69 ang common between Luzon Datum and PRS 92. So this is the national framework of national geodetic framework na. So again, triangulation networks of 1911 gi-establish sa USCGS, then naka-establish sila og Luzon Datum 1911, and it was modified until niabot na siya og PRS 92 nga datum. So which is ang output niya is 330 ang first order, 101 ang second, and 36 ang third order. So this is the whole program for PRS 92. So more on what we call this one, tanan na nga klase na pwede mahimong reference, like for example for gravimetric survey, for leveling, tidal station establishment, national structures and regional and national spatial structures, cadastral data, topo base map, and so on. So mas harmonious na, or what we call this one, holistic na ang approach ni PRS-92 since kay new technology ang gigamit, so daghan nga klase nga data ang pwede ma-gather. So this is the trend on the triangulation in the Philippines. So as a history, as a historical background, first is ang primary triangulation network in the Philippines, which was began on 1901 until 1927. So this was established by USCGS. So ang coordinates were being manually computed and adjusted. So network established generally very weak structural with stations widely scattered throughout the island. So as you can see, mo ni siya ang mga triangulation networks nga na-establish during sa 1901 to 1927, which is ang Luzon Datum. So as you can see, more on kasagaran na aragid sa coastal areas, wala kay siya sa mountainous. So mo nang weak ang iyang structural sa network, And then next is, it was upgraded into Philippine Reference System of 1992 or PRS-92, which began in 1989 to 1992. So this was a modified Luzon Datum. Same lang gyapon ang iyang reference ellipsoid, si Clark spheroid of 1866, and it was established through GPS technology. Iyang origin the same, Station Balanacan, and nana siya geoid spheroid separation at the origin, which is 0.34. So kaning geoid spheroid kanang sa formula bito nato na H is equals to H plus N, diba? So Cn mao ni siya si 0.34 si geoid sphere. Local definitions of the WGS84 datum using transit Doppler and GPS defined to facilitate the processing of the baseline adjustment. No? So, of course, GPS ang igamit. So, ang iyang output is from WGS84. So, it was then processed and adjusted so that it will fit to Philippine references. Transformation parameters between PRS-22 and WGS-84 are available. So, in this time, sa PRS-22, available na itong kanang transformation from WGS to PRS and PRS to WGS and vice versa. So, next is the PAGENET. So, the PRS-92 project extended version of the PRS-92. So, diri sa PAGENET, more on the full-scale and nationwide implementation of PRS-92 as a standard reference for surveys and maps. So this was the upgraded version of PRS-92, wherein there is a densification of geodetic control points, benchmarks, gravity stations. So this is in this project also, so na-establish ang gitawag na nga Philippine Active Geodetic Network or PAGENET. So sa PAGENET, so more on what we call this one, mas real time ang iyahang matag sa mga data, no? And also establishment and upgrading of tidal stations, I-systems development support, research and development, and policy formulation. So more on upgraded version, modernization of the PRS-92 in this part. Next is the extended pa jud, mas extended version for PRS-92, modernization of the PAGENET or the Philippine Geodetic Reference Systems. So in this part, ni-adapt na si Philippine og geocentric datum. When tag geocentric, so ang Earth is the center of the what they call this one. Center niya is nasa ang Earth, pag naay Earth, ang center niya is naagid sa tunga, dili siya sa iyang centroid. And development on and refinement and deformation of models, migration to semi-dynamic geocentric datum. Next is ang establishment of Philippine Geodetic Vertical Datum. So kanang geoid models nato. So yung kitawag na Philippine Geoid Models. So ang pinaka-latest ata is ang PGM 2018 if I'm not mistaken. Densification of gravity stations, unification of national vertical datum, and strengthening the core competencies on Geodesy, the revision of laws, standards, and procedures, research and development, and the capacity building of IEC campaigns. So, muna siya ang trend sa triangulation in the Philippines. So, this is the PAGENET project, 2007 to 2010. So, passive ang pagdaghan sa mga geodetic networks. And passive sa pasabot sa passive is kung establish na siya at that reference epoch or that reference time, so that will be its coordinates, but we all know na ang Earth is dynamic, so the Earth is moving, so there might be changes due time. So sa PAGENET na nga part, active na ang gigamit na technology, which is continuous ang iyang pagkuha og information so that ma-adjust niya in a real time. If na earthquakes, for example, pag na earthquakes na movement, so possible na changes sa coordinates kung passive ato ang hisgutan. And for active, continuous ang iyang pag-adapt og informations. And for the reference systems in the Philippines, so this network is for the Luzon datum. So makita nimo nga mas gamay ra siya, gamay ra ang na-establish. While sa PRS-92, mas dense na siya kay mas daghan na og reference. Na kuan na siya na distribute throughout the country. And for a loose definition, think of the ellipsoid as defining size and shape. The datum then fixes the ellipsoid to the Earth. No? So, as we all know, and as we discussed, no, from our previous lessons, no, si Earth is not a perfect sphere. No? So, somewhat like geoid siya, no? Naa siya mga variations, irregular ang iyang shape. So, para mo fit in siya, naatay gitawag nga ellipsoid. No? Ellipsoid. But the ellipsoid was fixed to Earth at different locations, no. Dili man jud siya, syempre gi-fit in raman nato ang ellipsoid, no, sa geoid. So naay part na mas layo siya sa ellipsoid, either nisaka siya sa ellipsoid na surface or nibaba. So mao nang some part lang are being fixed or nagtugma jud siya. And Luzon Datum, so this is the parameters for Clark spheroid 1866. We have semi-major axis, semi-major minor axis, and flattening. Datum origin, the Balanacan station, no? Actually, station Balanacan is a fort, no? It's a fort Dungguanan, no? Dungguanan sa Fort Balanacan, Marinduque Island. So makita na siya sa Marinduque Island. Ang latitude is 1333.41 and longitude is 121.52.03. Ang iyang reference direction is from south, no, which is from station Baltazar. Mo ni iyang azimuth. And sa Luzon Datum, ang iyang geoid sphere separation or katong N is 0. No? While sa PRS is 0.34 meters na siya. And another facts about Luzon Datum. So it's a Philippine triangulation network that was established by USCGS from 1901 to 1942. Narrow chains, no? The network consisted of narrow chain of quadrilaterals. Remember sa inyong control survey, no? Chain of quadrilaterals ang ilang gigamit. And it was mostly located at the coastlines. So Luzon Datum 1911, ang iyang published accuracy is modified second order, not homogeneous. Ang iyang baseline is about 1:100,000. And it was static siya. Static ang iyang coordinates at akong discuss kaganina, no nga. I-establish na siya at that reference epoch at reference time, but update na siya if you are going to observe in murag i-observe nimo siya kung naabay changes or wala, no. And it was also non-geocentric, no? Naradang explanation sa static, no. Static datum coordinates are fixed at a reference epoch. Say reference epoch katong time ni imo na siyang establish and gi-observe. If points are re-observed over time, the new coordinates deviate from the original values. It's because we all know the Earth is moving, Earth is dynamic, so na changes. So let's go to the Philippine reference system of 1992. So again, no, si Philippine reference system of 1992 was the modified version of Luzon Datum, and the retained original coordinates and orientation of origin, and nalang siya, nag-change lang is ang geoid sphere separation. Sa Luzon Datum is 0, so sa PRS 92 0.34 na siya. So the PRS 92 Geodetic Control Network established using GPS technology. GPS na ang gigamit sa pag-establish. And transformation parameters relating to GPS datum to the local horizontal geodetic system was also established. So PRS 92 is a satellite based, no, technology. So nagagamit na sila og satellites, GPS satellites. Ang iyang accuracy is for first order 1:100,000, more homogeneous than Luzon Datum 1911. Still non-geocentric, static datum, no. ang nagkalain lang ani is ang method na um, pag-establish, no? So una triangulation network using transit, karon is uh, ano na siya, GPS technology ang pag-establish. So this is the illustration, no, on what we call non-geocentric datum, no. Non-geocentric, dili ang center sa dili ang earth centered, no, or earth mass center, kundi ang center sa ellipsoid ang gigamit, no. Non-geocentric. Pag mo tag geocentric, ang earth mass ang gibasihan, no. In this case, no, so this is the real surface of the earth, no, kani siya, and gifit in siya sa nga mo fit sa ihang ellipsoid, which is ang kaning ellipsoid. Kung unsa ang gigamit nimo nga mo fit in niya ellipsoid, ang center adto niya mo to siya ang center sa imong datum. Whereas kung geocentric, ang earth mass, no, ang iyang center of gravity na adira. So in this case, naa siya deviation niya 215 meters. Dako na siya kaayo, di ba? So that's it. And here is also the PRS 92 accuracy standards, no? Na ay 0 accuracy, first, second, and third. No? So ang iyang relative accuracy is 1:1 million pag 0. First is 1:100,000. Second is 1:50,000. And third is 1:200,000. 20,000 rather. And for cadastral survey, na primary, second, and tertiary. Primary, secondary, and tertiary. For primary, 1:200,000. Secondary is 1:10,000. And tertiary is 1:5,000. So there are many reasons, no, why our coordinates, no, are changing, no. So as we all know, again akong ibalik-balik, Earth is moving, so naadjud na changes, no, due time. So ang reason nga nung na changes ang coordinate is due to gradual and imperceptible deformation. For example, tectonic plate motion, earthquake events, no, post-seismic relaxation, slow slip events. So mo na siya ang mga reasons nga nung naatay changes in coordinates. For example, that one, no, so na changes, no, on the tectonic plates movement is the post-seismic relaxation. So that one. And as we this is from the study, no, of the many of the researchers, no, as i-analyze nila kung padulong ang changes in or a motion kumbaga sa tectonic plates at a certain area. So another one is ang again, this is also an example, a study of many of the researchers on the changes in land masses. Talking about geographic position, the complete geographic position of points of reference shall be expressed in latitude, longitude, and elevation. So ginatawag na siya usually as a complete datum. Pag ang specific nga geodetic control is naa siya latitude, na siya longitude, and na siya elevation. So you can see this in the section 41 of DAO 1998-12. The geographic position of the control point shall be derived from the adapted coordinates or previously established station as referred to the standard datum by the network of triangulation, trilateration, traverse, leveling, GPS, or by any other method recognized standards. So pwede nimo siya butangan og specific information such as latitude, longitude, and elevation, but only through this method, no, triangulation, trilateration, traverse, leveling, or GPS technology, or any other method, no, but also dapat na siya recognized standards. For example, natin triangulation, no, trilateration, and traverse. That's it. So the standard datum for the Philippines shall be defined as geographic coordinates of the triangulation on the of the coast and geodetic surveys known as Station Balanacan. So again, ano ang iyahang latitude, longitude, and geoid-spheroid separation. So, mo makita dito sa Station Balanacan. So that was the datum origin of the Philippines for Luzon Datum 1911. And imong makita is kani siya for Station Balanacan. And makita nimo siya sa Mount Mugpog, Station Balanacan, Marinduque Province. The Philippine Reference System of 1992 is the new reference system for all surveys and maps in the country pursuant to Executive Order number 45. No? Executive Order na ni siya. So, mo ni ang law nga nag-mandate nga si PRS 92 ang gamiton for all the surveys and maps in the country. No? That was dated on January 5, 1992. It is also known as the Philippine Plane Coordinate System, Transverse Mercator Philippine Reference System of 1992. So, itawag na siya PPCS TM PRS 92. To distinguish it from the PPCS of 1965. So, ang kaning Philippine Plane Coordinate System, naka-northings and eastings na siya. No? So, ang tawag niya is ang kaning PPCS TM PRS 92. A transition period after year 2000 is allowed in order to integrate the existing surveys into the system after the PRS 92 shall be recognized as the sole reference. No? So since ang iyahang executive order naman jud siya no on January 5, 1992, so gitigaan until 2000 para i-integrate, gitigaan siya until year 2000 para ma-integrate ang all the surveys into PRS 92. Kay si PRS 92 na karon ang sole reference in the Philippines. So, positions read out direct from the GPS receivers are referred to as the World Geodetic System of 1994. As such, the geographic coordinates are geocentered, Earth-fixed coordinate system defined by global positioning satellite ephemeris. So, since pag GPS or GNSS receivers ang imong gamiton, so ang imuhang coordinates ana is naka-base na siya into WGS 84. So, pag WGS 84, naka-geocentered na siya. Kung tag-geocentered, itong areahang Earth mass, no? Center of the Earth mass. And Earth fixed, no? Defined by the Global Positioning System. So, kinahanglan natin siya i-transpose or i-transform rather, no? Into PRS 92 from WGS 84 going back to or i-transform into PRS 92. So, the geocentric Cartesian coordinates must be transformed to Cartesian coordinates. No? On the Luzon datum with the following parameters. No? Since naka-WGS man, so geocentric Cartesian, i-transform na to siya into Cartesian coordinates of the Luzon datum. So, this is now the formula for transforming or transformation from WGS down to PRS 92. This is the formula. I hope you are familiar with this one. No? And this is the parameters, no? Ang change in X, change in Y, and change in Z is kani. Sa X is 127.62195. Sa Y, 67.244.24478 meters. And sa Z is 47.04305 meters. Inapod tayo rotational X, rotational Z, and rotational Y, no? Na parameters. For rotational X, negative 3.06762 seconds. And for rotational Y, 4.90291 seconds. And si Z is 1.57790 seconds. And ang iyang scale parameter is 1.06002. So this is the positional accuracy for PRS 92, no? So first order 1:100,000. Second order is 1:50,000. third is 1:20,000, and fourth order is 1:10,000. For vertical accuracy, no, sa PRS, sa heights na ni siya ang kaning vertical accuracy. For second order, 8 millimeter times the square root of its distance, no, separation, distance of separation. Third order is 12 millimeters times the square root of the distance, no, between the two. But we are not going to detail more about this one because ma-discuss ni siya sa inyong geodetic surveying class na. And here is the parameters for WGS84. We have semi-major axis. Since gamito na to ni siya, labi na sa pag-solve sa transformation. Semi-minor axis and ang iyahang inverse flattening. So, I guess na-discuss na to nino from the previous discussion na to. And sa WGS84, no, it was designated by the NEMA or the National Imagery and Mapping Agency as the preferred ellipsoid and datum for all the mapping, charting, and geodetic products. No, mo nang si worldwide ni siya nga ginagamit, no, since it's geocentered. And geocentric, no, coordinate system to ensure the accuracy and easier user interface, no, si WGS84. And the WGS84 provides a basic reference for all the mathematical figure of the Earth. No. So, tanan formulas was derived mathematically to have easier and more accurate na output. No. Kaya since naka-geocentric na siya. Manang acknowledge siya worldwide. And it also provides a means of establishing various geodetic datum to Earth-centered, Earth-fixed, or kanang gitawag na to na ECEF coordinates. So, WGS84 ang gigamit for establishing that one. And lastly, for WGS84, so in determining the WGS84 ellipsoid and its defining parameters, the WGS84 Development Committee closely followed the procedures used by International Union of Geodesy and Geophysics, or IUGG, who had already developed the Geodetic Reference System of 1980, or GRS 80. So, pag-establish, no, sa WGS84, nagid sila gi-follow na procedures na established by the International Union of Geodesy and Geophysics nga standards, which is kaning si IUGG, sila pod ang nag-establish aning Geodetic Reference System, or kanang gitawag na itong GRS 80. And in WGS84, there are 4 parameters were developed: the semi-major axis, the Earth gravitational constant, or kaning GM, and the normalized second degree zonal gravitational constant, and lastly is the angular velocity of the Earth. So these are the 4 parameters was established to used no, to develop the WGS84.
Alright, so we are now down to the transformation of horizontal datum. For transformation of geodetic data between reference datum, the history of geodesy must include the discussion of the positioning for one of the fundamental goals of geodesy is to precisely define the position of points in the surface of the Earth. So that's why we are studying geodesy, because we need to determine the locations, no? The exact location in the surface of the Earth. In order to do this, it was necessary to define some starting point and reference ellipsoid. So like this one, no? Sa kaning example sa kilid sa pinahanglan, nakitay reference, no, or ahata magbase sa ato ang mga coordinates. And an alternate method of triangulation and trilateration computation is known as projective method. So again, alternate method daw of triangulation and trilateration computation, ang tawag niya is projective method. This projective method has not been widely used because of the lack of knowledge of geoid undulations, as historical networks were determined. In principle, we should define whether we are working with a development of a projective geodetic network. We should also distinguish between horizontal and vertical network transformations. Lahi ang sa horizontal, lahi po ang sa vertical. So what is datum transformation? So a datum transformation is a set of math formulas. So mathematics formula itong gamiton that converts point coordinates from one datum to another. Diba? Since lahi-lahi tag ellipsoid, lahi-lahi tag reference, so dili gid magkaparehas ang atong mga coordinates. So therefore, naani siya si datum transformation from nga kinalang to i-convert or i-transform gikan sa isa ka datum from one datum to another datum. Datum transformation takes place in three-dimensional space, but you can get a sense of how they work from a two-dimensional. The challenge is to get two sets of points into alignment, say by aligning the points in datum 2 with the points in datum 1. So mao ni siya ang more challenging no sa pag-transform sa datum, it's because we need to overlay them no nga dapat maparehas sila sa isa ka, like for example na isa ka space tapos atong i-overlay ang duha ka datum para ma-align nato ang mga points no. So the first step daw for datum transformation is to put two sets of points into common coordinate space. Like for example, mao nila ang common coordinates kaning grid no. So, na isa ka datum kani no? And another datum is kani. So ato siya ibutang sa isa ka place nga pwede na to sila i-align no? Then next is we need to align them no? The origin. First is we need to align the origin of two systems by moving a certain number of units in an x direction and a certain number of units in y direction. Then we're going to rotate the axis into alignment. Like for example, no, kaganina kani, no, ilang origin is atuwa silang i-align. No, ato silang ang origin aning isa atong i-overlay sa origin sa isa. Morning may tabo, no? After that one atong i-rotate nga si x-axis sa isa ka datum same with the x-axis sa another datum. Parehas na ani, no? And again, ato pagid siyang i-align kay since dili sila magkaparehas og extent, no, ang black ug ang red. So ato siyang i-align nga parehas na gid sila. No? Therefore, ma-overlay na dayon silang duha. No? The process is similar in three-dimensional space except that you are working in z-axis as well as x and y-axis. In a datum transformation, coordinates in both from datum and the two datum are converted from latitude, longitude into three-dimensional Cartesian coordinate space like x, y, and z. No? Next thing is the math, no, is done to align the coordinates. So, si mathematic formula na din ang bahala to align those coordinates. And finally, the coordinates are translated back into the longitude, latitude values of the two datum. So there are techniques no on how to transform datum. First is one atay gitawag na 7-parameter or Borsa-Wolff transformation. In this transformation, it assumes that the linear distortion within the network, and it uses 7 parameters no, like translation, rotation, and scale. And it needs at least 3 points with coordinates in both datums and doing at least least squares feet. No? And we have also Molodensky transformation. It uses 5 parameters. No? 5 parameters only. 3 for the datum shift and 2 for the difference in semi-major axis and flattening. And in this transformation technique is it assumes internally consistent network and it has a limited accuracy. Next is the multiple regression equation or MRE transformation. It better fit for modeling nonlinear distortion, or it creates surface of a distortion. It appropriate for transforming continental size land areas and not to be extrapolated outside of the area of intended use, like because large distortion over short distances may occur. And it requires many points and very complex to derive. But in our case, no, sa pag-transform sa tuwang datum no, from WGS to PRS, we are using this 7-parameter transformation or Borsa-Wolff. So, mo ni siya. No? The seventh parameter or Borsawolf transformation. The transformation involving three translations, kani XO, YO, and ZO. Three rotation, RX, RY, and RZ. And a scale. Munang 7 sila kabuok. The 3D rotation matrix describes the rotation of the coordinate system in order to become parallel to one another coordinate system. So, nasa gitawag nga direct transformation, na po siya inverse. So, these are now the formula for transformation from WGS 84 to PRS 92. So, this was based from the Dow 1998-12, no? So, kanina formula is gikan na siya dito. So, we have here the formula x2, y2, and z2 is equals to delta x, delta y, and delta z plus 1 plus the scale times 10 raised to the power of negative 6 times 1 rz negative ry negative rz 1 rx ry negative rx and 1 times the x1 y1 z1 where si x1 o x2 y2 and z2 so kanisha these are the transform Cartesian coordinates, no, ang na-transform or ang atong gipangita, no, while si change in x, change in y, or change in z, or the delta x, delta y, delta z, these are the shifts of the change in the origin. So given ni siya. And we have also Rx, Ry, and Rz. These are the rotation of each axis. No? And we have the SC or the scale change in parts per million. Muna siyang naka-ratio into negative 6. Then x1, y1, z1. These are the coordinates to be transformed. So kani siya. Ang ato siyang given yung coordinates nga itong kuhaan o transform ng coordinates. So again, this is the formula for WGS to PRS 92. WGS 84 to PRS 92 nga transformation formula. No? So, sayo na siya memorize on class, no? Like, diri ang lisod lang diri nga part is ang kani, no? The 3x3 matrix. Pero, na ako'y mahatag nga tip no unsaon siya pag memorize no sa transformation sa diri ra pud nga part no kaning 3x3 kay murag kani man ang lisod memorize no. So first tip memorize this 3x3 matrix is first the diagonal of the 3x3 matrix is equal to 1. Manay first tip no. Right, balik ta. So first tip is ang diagonal is equal to 1. 1 na tanan. Second tip is the right side of 1 in each row is equal to the right side of each row is positive, always positive. Like for example, in the first row, ang positive daw ang right side. So therefore, sa 1, positive sa 1, right side sa 1 is positive, no? RZ. So tama, no? And sa second row, ang right side sa 1 is positive RX. So tama. The next is the third row or the last row. Sir, wala may right side. So naara di sa pikas. Ang right side is si RY, no? So, sakto ang number 2. Then, number 3 tip is, again, kung positive ang right, therefore, ang left is negative. For first row, sir, walay left side, naara. So, negative RY, sakto, no? Next is, next row, left side sa 1, negative RZ, sakto. And for the third row, left side sa 1 is negative RX. So, sakto siya. Last tip is, for memorizing the 3x3 matrix is, we need to denote this one as the first column is X, the second column is Y, and the third column is Z. No? So, for the fourth and last tip, since na-occupy naman ni 1 ang column sa X, Therefore, ang mabilin na lang si y ug si z. Since y na lang ug si z, ato ra siyang i-interchange, no? Si y na diri sa z nga column, and si rz is na siya sa y column. Interchange lang siya, no? But the second and third na tip is retain lang gyapon siya. No, for second row, no, as you can see, na-occupy naman ni y, na-occupy naman ni 1 ang y. So therefore, ang mabilin na lang na variable is si x o si z. So interchange na to siya, si rx na siya diri sa column sa z, and si rz is na siya sa column sa x. Again, tip number 2 and tip number 3 is always retain. Last for this row is na-occupy na si z nga column, si x na lang og si y ang mabilin atong i-interchange. Therefore, si ry is na siya sa x column, and si rx is na siya sa y column. Interchange lang siya. Again and again, tip number 2 and tip number 3 is always remain. So, based on the Dow 1998-12, the signs of the parameters shall be reversed when transforming from Luzon datum or the PRS-92 to World Geodetic System of 1984. So since kani nga formula is WGS to PRS, for its vice versa, which is PRS to WGS, kinahanglan na to i-reverse, no? I-reverse nato ang sign of the parameters. Like for example, sa shift or the translation, i-change nato na siya. Then the rotation atong i-change, pati ang scale atong i-change ang sign. Of course, dili ma-change ang coordinates, no, kay given coordinates kay mao magid atong gusto kuhaan. So dili ma-change. Ang tanan parameters lang, the 7 parameters must be reverse ang iyahang sign. So these are the given, no, nga numbers and digits, no. For translation, so this is from WGS to PRS-92 ha. So for translation, ni siya 127.62195 meters. Sa Y, 67.24478 meters. Sa Z, 47.04305 meters. For rotation X, negative 3.06, no? 762 seconds. No? Naka-second siya. For Y, positive 4.90291 seconds. And for Z, positive 1.57790 seconds. And we have a scale parameter nga given 1.06002. Again, these are the given digits, no? From WGS to PRS. But if we're going to do it vice versa, which is from PRS to WGS 84, ma-change ang sign ani nila pito. Like sa translation, mahim na siyang negative, negative, negative. Sa rotation, ang X mahim na siyang positive, si Y ma-negative, si Z ma-negative. And sa scale parameter is ma-negative. So, alright, well, to solve this one, no, the sample problem number 1, we are going to use the calculator. No? But in your exam, kinahanglan, or sa inyong quiz, though nagamit ako calculator, pero dapat na ko makita sa inyong solution na nagbutang mo dito og shift solve. No? Using the calculator, press shift, then solve, or press shift, then mode. So, dili siya ingana, no? Though ako ang pamaagi is kani, no? Pero I want you to create a solution na systematically at the same time formal, no? Formal siya. So, unta na masabtan ko ninyo anang part, no? So, first, to solve this problem, no, we need to store these values, no, kanang translation, rotation, and the one nga coordinates nga ato siyang gusto i-transform, no? So first, let's store the value of delta x in memory A. So let's type 127.62195. Then atong siyang i-store sa memory A. So shift recall A. So na-store na siya sa memory A. Then AC. Next na po is si translation Y or si delta Y. So that's 67.24478. Then store, shift, recall B. So sunod na siya sa memory B. AC. The next is translation Z or the delta Z. That's 47.04305. Then shift, recall C. So nasulod na siya sa memory C. Kung tanaw na to na siya, kung sakto kung na store ba gyud siya, so i-recall A lang siya. So muna siya ang value. Then recall B, muna siya pud ang value. Then recall C, kada pud ang value. Muna na yung value sa memory C. Alright, so the next one is ang rotation X. Ang rotation X is negative 3.06762 seconds. But first, let us all convert this into radians. To convert that, so again, negative 0 degrees, 0 minutes, then 3.06762. Ito ba? 06762 seconds. Times, kinahanglan to siya i-radian, ato siyang i-times of pi over 180. Then equals, ana nga value, ato siyang i-store sa memory D. Na siya, memory D. And next is rotation Y, 0 degrees, 0 minutes, 4.90291 seconds times pi over 180. Alright, so we have this value. Ato siyang i-store sa memory E. Now, and for rotation Z, again, 0 degrees, 0 minutes, 0 seconds is 1.57790 seconds times, ito siyang i-radian. Radian over 180 is equal to this one. Then ato din siyang i-store sa memory F. Next is sa kaning pong ang atong value nga gusto i-transform. Ato siyang i-store sa X, Y, and M. For X, we have negative 3274,103.818. 3274,103.818. Store na to siya sa X. The next is 5266,724.77 or 0.477 pala. 477. So 5266,724.477, store na to siya kang Y. Lastly is 148 5854.9. No? 148 5854.9. Store na to siya sa memory M. Alright, so to do this one, ito naman siyang na-store tanan ang value. Ato na dayon siyang balik na sa formula, which is kani. The formula is kani. So we are going to treat this matrix as matrix A. This one is the matrix B, and matrix C is kaning pinakalas. So ato na siyang i-input sa matrix. To do that, just mode matrix, mode 6. Mode 6 matrix, nato siya matrix A, matrix B, matrix C. So ato sang unahon og ato siyang unahan og sudlan ang matrix A. So press 1. So unsa daw siya nga klase nga matrix? 3 by 3, 3 by 1, 2 by 2, 3 by 2, 2 by 3 and 2 by 1. So atong matrix is 3 by 1, atong i-click ang 3. Alright. Input na to ang value, si delta X, delta Y, delta Z. So mao ni ang mga values nga atong gi-store sa A, B ug C. So kani naara, di ba? A, B, C. So ato siyang ibutang na diri input nato siya. To do that, so ikuan na siya, no? Alpha A, then equals, sumutang na, no? Next is delta y nasa b equals, then alpha c na which is ang rotation z or translation z, c equals. Alright, so nasudlan na ato ang matrix A. AC lang, AC ha, AC ang i-press, ayaw ang on. AC lang siya class ang i-press, AC. Then ato na pong sudlan ang matrix B. So para masudlan ang matrix B, shift matrix, asa man si matrix, okay, shift 1, okay, shift 1 ay shift 4 pala, no? Shift 4, then dito ta sa dimension 1, shift 4 1, then namili dayon ta matrix A, B, or C. Atong sudlan si matrix B, atong i-click si 2. Matrix B na to is 3 by 3, press 1. Alright, so ato na din ibutang dari ano kaninga matrix. So 1 equals, ang ato ang rotation Z is naa sa memory F, no? Recall alpha F. Alright, mali. Alpha F equals, no? Sunod, negative RY. Negative, ang atong RY is naa sa memory E. Alpha E. No? So, pinadayon siya. Next is negative RZ. Negative RZ, ang RZ is naa siya memory F. Then 1. Then RX. Si RX is naa sa memory D. No? Then RY naa sa memory E. Then negative RX is naa sa memory D. Last is 1. Okay? Then AC. Again, ayaw siya i-on. Ayaw, do not ever press on kay mawala to tanan ang imong distor. AC lang. AC. Next is ang matrix C. So balik na punta, shift 4 dimension 1, then sunod na to ang matrix C. So ato ang i-press ang 3. Since 3 by 1, so 3 again. So ato isulod si X1, Y1, Z1. Kani nga mga memory is naa siya sa X, Y, and Z. X, Y, and M pala. X, Y, M. So therefore, ato ibutang, so X is nasa X, then Y is nasa Y, and si Z is nasa M. Right. Okay, we are all done sa pag-input sa matrix. Again, AC lang, AC. So to solve this one, no, ato lang siyang i-parihas aning forma, no. So matrix A, atong ibutang si matrix A. So atong pagbutang sir, so shift matrix 4, no. Atong ibutang si matrix A. So therefore 3, no, matrix A plus, no, 1, no, 1 plus pila tong scale factor. Atong scale factor is, alright, tara, 1.06002 times 10 raised to the power of, kaya ang gibutang diri sa ato ang equation is times 10 raised to the power of negative 6. Then close parenthesis times matrix B. Ibutang si matrix B. Shift 4 matrix B. Si 4 po ang ibutang. Then times matrix C. So shift matrix 5. 5 na dayon. That's it. Then equals. So what na to siya? Muna na yung answer. So tanaw na to kung check ang atong answer. Alright. Nara. So negative 3273,974.696. Alright, so kay daghan naman nig value, no. Daghan naman ni siya og decimal points. So ang kaya ra niya ma-display sa calculator class is 3, no, 3 decimal places. So therefore, sakto atong answer sa x coordinate, which is this mo na ni ang coordinates nga transform, no, from WGS84 mao ni ang transform coordinates into PRS92. For y kasi y. Yan. For y, we have 5266,800.253. So again, 3 decimal places lang iyang kaya. Kaya kani gisolve man ako ni siya class kay through Excel, no? So mo nang daghan kay siya points na. Pero kani kay calculator tulo lang ka decimal places ang iyahang makaya o display. The next is ang Z, no? 148,5904.021. Tulo iyang kaya butang. So that's it for PRS to WGS 84 na transformation. So another sample problem, no? So this is the problem, no? Given the datum coordinates from WGS 84 ellipsoid, so therefore kaning mga values, no, is from WGS 84. So calculate the transform coordinates in PRS 92 ellipsoid. To do that again, no, parehas lagi po na itong gibuhat ka ganina. So since kay kaning mga parameters is from WGS to PRS, so ato na dyan to i-retain to atong gipang save, no, mga rotation X, sa memory A, rotation Y which is nasa B, rotation C which is nasa Z which is nasa memory C. Then we have, translation pa ito kayo na class. So, again, translation X nasa A, translation Y is nasa B, and translation Z is nasa C. No? Next, as ang rotation X is nasa D, which is nakaradya na siya. Next is ang E, which is mo ang rotation Y, and C. Z, rotation Z is nasa memory F. And scale parameter the same, and ato lang utrohon is ang kaning given na nga XYZ karon. So kani mo ni siya ang given XYZ sa atong problem kaganina, and we need to store this one in memory X, Y, and N. To do that, again, negative 3365522.17233 3365522.17233 ato siyang i-store sa memory X. Next is 5208,781.33858 ato siyang i-store sa memory Y. And si Z is 148,5854.89955. 148,5854.89955 store sa memory M. Again, matrix napunta, no? Shift mode, mode lang pala. Mode matrix 6, no? So first atong sudlan si memory matrix A. So baliktaan ni dirita. Okay, this is the formula now. So matrix A is 3 by 1, so click 3. No? Atong isulod si translation X, Y, and Z. So mao naman ni siya, no? X, mo na itong gisulod kay ganina. Atong gisulod nga matrix pala. Ato na lang i-modify, no? Kay same raman tao, nalahi raman siya sa matrix C. So ato lang yapon i-run through kung sakto ba dyan. Translation X, Y, and Z. So nana siya sa memory A, B, ug C. For matrix B, no, again AC lang, shift matrix dimension 1. No? For matrix B, 2. 3 by 3. So mo na itong gisulod ka ganina nga value, no? Ay 1, so kani is matrix, nani siya sa memory F, kani is memory E, no? E nga eagle. Then kani next is this is in memory F 1, then this is in memory D, kani in memory E, tapos kani is memory D as in dog, then 1. Then ma-change lang ato ang matrix is a matrix C kay ang given. Shift matrix dimension 1, then matrix C 3 by 1, so 3. So lahi man ni siya, no, di man ni mo auto-auto given. Ano ko tong given? Alright, ano tong given? Okay, this is 1, no? Dili man siya mao. So ang X, Y, ug Z is naa siya sa memory x, y, ug m. So for x is atong alpha x equals, then alpha y equals, and for z is nasa m. Alright, so muna na siya karon, no? Then 39917. Okay, so we're good. Baliktad to nga atong equation. Alright, so shift matrix A ato ibutang. So matrix A plus 1 plus ato ang value for scale. This is the one. So 1 plus 1.06002 times 10 raised to the power of negative 6. Matrix B, shift matrix B is nasa 4. Then shift matrix C, nasa 5. Then equal. Now, check na to kung sakto ba. Ito ang answer. Alright, so muna siya. Negative 3365393.59. Sakto. So, next sa Y, 520-8857.753. Then last is sa Z, 1485900.985. Therefore, sakto ato ang sample. Sakto tong pag-solve sa sample problem number 2. So another transformation of datum problem, no? So given the datum coordinates of PRS92, which is kani x, y, and z, calculate the transform coordinates in WGS84. So vice versa na punta, no? Vice versa from PRS to WGS84. No? So kani ang PRS atong kuhaon ang WGS. To do that, no, again, so based sa ato ang discussion a while ago na pag vice versa, no, which is from PRS padulong na sa WGS, ma-change na ang iyahang sign, no, sa kaning mga parameters, no, the 7 parameters. Pag ganina positive ni diri ang translation x and y, rotation is x lang ang negative, the rest is positive, and si scale parameter is positive. So karon kay vice versa man ta, PRS to WGS, so reverse na to ang sign. So mahimo na siyang negative, negative, negative. Ang rotation x mahimo na siyang positive, then y ug z ma negative, ug si scale parameter ma negative, no? So to do that, again, let's store the value, no? First is for translation x, so negative 127.62195. Store sa A. Next is negative 67.24478 is to point pala, point ay no mali ta class. Alright, so 67.244 pala, 24478. Store sa memory B. Then negative 47.04305. Store sa memory C. Kung i-check, negative, negative, negative. For rotation X, we have positive 0 degrees. Ato pati i-convert sa radian. Positive 0 degrees, 0 minutes, 3.06762. 0.6762 times pi over 180 equals, I know, syntax error kaya wala siya nabutangan of degrees. Careful mo na class, ha. So again, mo yung value, so ito na siyang i-store sa D. Next is 0 degrees, 0 minutes, pila man, negative pala class, napalay negative, negative 0 degrees, 0 minutes, and pila man ka seconds, 4.90291. Sakto ba? Yes, degrees times pi over 180 over 180. So we have a value of this one, ato siyang i-store sa E. Last one is negative 0 degrees, 0 minutes, 1.57790 90. times pi over 180 equals, sama na siya. Siya i-store sa memory F. For x, y, and z, no? For x, y, and z, we have negative 3364,050.32966. So 3364,050.32966. Store at memory X. Next is 5209827.43419. 5209827.43419. Store sa Y. Lastly, sa Z, 1485763. Alright. 1485763.03436. Store sa memory M. So, we're good. Balik na sa tong formula. Kani? So, matrix A. So, mode matrix 6. Atong sudlan ng matrix A, 3 by 1. So, 3. So, atong isulod si transition X, Y, and Z. So, nasa sa ABC. Alright. Balik ta. Shift, alpha A equals alpha B equals and alpha C equals. Nasa ABC ha. Then, shift lang. AC. Then, matrix B, shift for atong sudlan, dimension. Sudlan na to ang matrix B. Yan. 3 by 3. Mali pala. So, balik ta. No? Shift matrix for dimension 1. Then, sudlan na to si matrix B. 2. 3 by 3 dapat 1 atong pilihan. No? So, dara siya. Then, 1 equals. So, RZ is na siya sa memory F. Si F equals. Negative RY. Si RY is nasa memory E. So, negative RY. Memory E. Then, RZ nasa memory F. So, negative RZ. Yan. Then, 1. Tapos, memory RX is nasa D. Yan. So, negative RY nasa memory E. And we have negative RX is nasa D. And 1. So, we're good for B. No? Next, shift matrix. Dimension 1. So, doon na to si matrix C. Which is 3. Right. Dapat 3 by 1. Nasa 3. So, ato isunod si X1, Y1, o si Z1. X1, Y1, Z1 nasa XYM. So, alpha X equal, alpha Y equals, and alpha M equals. We're good. So, balik ta. Atong ibutang, i-input na to ang formula, which is shift for matrix. Atong ibutang si matrix A. So, si 3 plus 1, since kay negative na atong scale, ma-minus na siya. No? Minus. Atong value sa scale, ibutang. So, negative 1.06002 times 10 raised to the power of negative 6. Then, matrix B, shift matrix B for, then shift matrix for matrix C equals nagsakto ta class, no? Atong check kung sakto ba ta, mo ni ang answer. Alright, negative 3364178.924. So check ta. For Y, 5209751.029. Sakto. Last, 1485716.898. So, therefore, sakto ato ang pag-solve and ato ang pag-process sa ato ang pag-solve on transformation parameters. Alright, so I guess that ends in our topic 2 for topic 2 of this course, no? So if you have question and if you have clarification regarding this topic, so you are free, no, to come to chat me through our Facebook page and give some feedbacks, no? Sir, naglisod ko kung saan pagaling to. Then I hope class na if ever mo ask mo question na clarification, be sure nga nagtanaw na ninyo ang video or natanaw na ninyo or naka-study na mo sa ato ang PDF, no, nga file nga akong gi-upload sa inyo ha. Kay kapoy kayong mag-isa-isa sa inyo ha, no, og kanang tubag niya same ra ang question, no. Again, please study first, no, before asking a question for me, para at least man lang mas ma-deep in pa nako og discuss sa inyo ha, no. Dili na ang basic ang akong ma-discuss sa inyo ha. Kay ang basic is na diri sa video lecture, tapos naa pod sa ato ang PDF file, PDF topic, no, which is detailed na kaayo, no, masabtan na siya. Then napadyoy supplementary nga video. So I hope na study sa tauna, no, before ta mangutana, no. Kay para lisod kayo jud og anang isa-isa kon ta mo, tapos napadyoy ko ilain trabaho, no, for project. So I hope, no, nga nakatabang ni nga video sa inyo to supplement your understanding in this topic, no. So I guess this ends our video lecture for now, and we'll see you, no, for another video lecture. Bye, God bless, and keep safe.